Hello everyone. In this video we're doing activity 6.2 in jamovi. So in this example we are looking at 36 people and measuring how often they use their cell phone while driving before watching a documentary about the dangers of cell phone use while driving, and then again after that. Right? So clearly in this case higher numbers are worse because we want people using their cell phone less while driving. So we're going to do repeated measures T by clicking on t-test and clicking on paired samples T. So we have two variables, their scores before, or the number of times they did the number of times they used the cell phone in busy traffic before the documentary and then after the documentary. So we're going to ask for a mean difference with confidence intervals around it, effect size with confidence intervals, descriptive statistics and descriptive plots, and then we have to decide on our hypothesis. So in this case we're doing a two-tailed hypothesis because we're looking at whether or not the intervention has an effect on people's cell phone use. So it's possible that watching the intervention means people lose or reduce their use of the cell phone while driving. But it's also possible that people actually react negatively to the documentary and actually increase their use for some reason, which would also be problematic. So we're doing a two-tailed test for this example. So our mean starting at time 1 was 5.67, and after the video at time 2 we have a mean of 5.19. So it looks like scores went down. Right? We have a standard deviations of 1.01 and 0.98 for these two groups, or not two groups, but for these two times. And so what we need to determine is, does that mean difference represent a true difference, or is it probably just due to sampling error? And if you scroll down, you can see these data also plotted on the graph below. All right, so we computed a t-test and obtained a t of 2.45 with 35 degrees of freedom. Right, we had 36 people in the study, so it's just n-1 for degrees of freedom. And the p-value is 0.02, which tells us that these results are unlikely to be due to sampling error. This is pretty strong evidence against the null. The difference between our means is 0.47. That's in raw scores. And the standard error of that difference is 0.19. So the typical distance we'd expect between those two means, if in fact the null hypothesis is true, is 0.19. We compute a 95% confidence interval around that mean difference and find that the mean difference, we're 95% sure that the true value is somewhere between 0.08 and 0.86 in raw score units. And when we look at the effect sizes, we find that we have a difference of 0.41 in standardized units, right, which is a moderate size effect. Now our 95% confidence interval shows us that the true difference, we can be 95% sure that it's somewhere between 0.06 and 0.75 in the population. Right? This is not a very precise estimate here. Right? We're saying that the confidence interval is somewhere between negligible to nothing and large. Right? If you want a more precise estimate of the effect size or the population parameters, you need larger sample sizes. Right? In this case, we only have 36 people there. Okay. So this is a better study than the one you did in activity 6.1 in that the people's actual behavior was measured rather than just their intent to use a cell phone. It was their actual use of the cell phone. And also the sample size is bigger, but still not sufficiently large for us to be drawing very firm conclusions there. Okay. All right, and that is all you need to do activity 6.2.